We are going to look at section 2.4, symmetry, even functions, and odd functions. An even function is symmetric with respect to the y-axis. And an odd function has symmetry with respect to the origin. And another thing we know about it is if the graph of f of x is equal to the graph of f of negative x, that function is even. And if the graph of f of negative x is equal to negative f of x, then that graph is an odd function. Now we have, I have three graphs here. And the first graph, y-axis, this graph is symmetric to the y-axis. So if I were to fold it, it would match up perfectly. It would be like a mirror image. Symmetry is a mirror image of the other side, of one side of the graph with the other side of the graph. So symmetry, so each side is the mirror image of each other. So when it's symmetric to the y-axis, we know that it's an even function. So if I were to fold this graph, the parts on the left and the right would come together, would coincide together and make one, it would be one perfect match. Now, when it's symmetric with the x-axis, it's not a function. The only two functions is the even function and the odd function. And we know that when it's symmetric with the x-axis, it's not a function because of the vertical line test. So if I wanted to do the vertical line test, remember that if it touches in more than one spot, it's not a function. But there still can be symmetry, with respect to the x-axis. But we only are going to be looking at the even functions and the odd functions. And then the third graph is symmetric with the origin. If I wanted to flip this graph around, I would get exactly the same graph when it's upside down or right side up, whatever way you want to flip it. If you flip it, then you would know that it's symmetric to the origin. Even if I draw a line here and cut it, divide it, you can see the symmetry. And with respect to the origin, that's your odd function. You can kind of remember because of the O's, origin, odd. In this example, they want me to look at the graph and see if the function is even, odd, or neither even nor odd. So we need to look at it to see if it's even, odd, or neither. So we know if it's even, we have symmetry with the y-axis. And if you have symmetry with the origin, it's an odd function. So looking at this graph, if I fold it along the y-axis, it will come together as a perfect match. So if I fold it, it will kind of come together as one. So this graph is symmetry with respect to the y-axis, and it's an even function. So this graph is even, an even function. I just fold it. You can see the symmetry that it's identical on both sides. They twins. So you can see that it's, if you fold it, it's going to line up perfectly along the y-axis. So this function here is even. Any questions on that one? So again, you had symmetry with respect to the y-axis, and it's an even function. And this one, we want to know if it's even, odd, or neither again. And so with this one, if I try to fold this one, I don't think that it doesn't look like it would match up perfectly across the y-axis. So it's not even. So it's not even. But if I were to flip this graph or turn it upside down, you turn your computer upside down if you got a laptop. If you got a big computer, don't try to turn it upside down. But most people have smaller computers. I grew up with big ones that were like the size of crates. So if I turn this function upside down, it's the same. And if I divide it through the origin, it splits up evenly. So this function, once I turn it around, it's the same graph upside down, right side up, whatever side you turn it on, flip it, and reverse it. And so this function would be odd. My pen. So this one is an odd function. So we only are looking at symmetry in respect with the y-axis and origin. The x-axis we don't do because it's not a function, and we only want to deal with functions. Now the graph was the fun part. Now here's the scientific, mathematical way of determining if something is even, odd, or neither. I thought I had an extra slide in here. All right, so if something is even, odd, or neither, so when we have an equation and we want to know, you can probably use it on a graph and calculate it and graph it and see what it is, but we want to do some calculations because we like calculations. So we know that if I'm given f of x and it's equal to f of negative x, the function is going to be even. And then if f of negative x, once I find f of negative x, if it's equal to negative f of x, then that function is odd. So there's a lot going on here. So let's put this in action. So the first thing we want to do, we need to replace the x, the f of x with we want to replace x with negative x. So everywhere that we see x, we're going to replace it with negative x. So this becomes negative x. So our input is negative x now. So everywhere I see x and only x, I'm changing. So everywhere I see x, I'm replacing it with negative x. So you want to write it in parentheses because there's going to be some movement going on with the function being, raised to a power. The x is going to be raised to a certain power. So you want to put it in parentheses so you know that negative x has to be raised to that power. So here, the first one, I have negative x raised to the fourth power. If I were to write negative x out 4 times, I'm going to get a positive x 4. So now that becomes positive x to the 4. And this what we have to do. Remember order of operations. Order of operations, you have to do parentheses first. So don't multiply negative 4 times negative x. You have to do the negative x squared first. So negative x times negative x is x squared. So when you multiply negative 4 times x squared, now you have negative 4x squared. You see that? So the negative x, when I raised that to the second power, I got x squared. And then I multiplied it by that negative 4. This is a negative 4, so I multiply that, and I got negative 4x squared. And plus 8. So 8 doesn't have an x. It stays 8. So f of negative x is equal to x to the fourth negative 4x squared plus 8. No, it's not going to always be the same. So if it's the same, if f of x and negative, if f of x and f of negative x are the same, then it's even. And if f of negative x is equal to negative f of x, then it's odd. If it's not in the two situations, it's neither. So now I know that my f of x is equal to x4 minus 4x squared plus 8. And then my f of negative x is x4 minus 4x squared plus 8. So these two and are the same. Therefore, since I got to this step and f of x and f of negative x are equal, the function is even. So the function is even. Now make sure when you replace it with a negative x. Sometimes students like to replace it with a -1 and thinking that it's correct, but it has to be a negative x. So do not replace it with -1, replace it with a negative x. And once you replace it, and if the functions come out exactly the same, if f of x and f of negative x are the same, it's an even function. So just let that marinate for a while. Do you have questions on it before I move on? There's a lot to take in. So first thing you have to do when they say decide whether f is even, odd, or neither, you replace x with negative x and work with the parentheses first. Do what's inside of the parentheses first, and then multiply the x's, your results from the parentheses, by the number that's outside. So go to the next one. So we still trying to decide if it's even, odd, or neither even nor odd. They very specific. The function even, odd, neither even nor odd. So the first step is to change the x, more over here, to negative x. So everywhere I see x, I'm replacing it now with negative x. So negative x cubed, or to the third power, if I apply that out 3 times, is going to be negative x cubed. There's no other numbers out there, so f of negative x is negative x cubed. So let's see if we need to see if f of x and f of negative x are equal or the same. And it looks like they are not. So f of x is not equal to f of negative x. So it's not even. Now we want to see if it's odd because we ruled out even. So we take negative f of x. So what we're doing, we are taking the original function, and then we're going to multiply it by negative. So the y part actually is multiplied. So the function is going to be multiplied by negative. So it looks like you want to write the negative and then put the function in parentheses. And now negative f of x is equal to negative x cubed. So we need to see if negative f of x is to f of negative x. Before we were looking at if f of x is equal to f of negative x. If f of x and f of negative x are equal, then that's even. If not even, then we are looking to see if negative f of x is equal to f of negative x. So let's see. Negative f of x is equal to negative x cubed, and now f of negative x is negative x cubed. We got it from here. So they are equal. So this function is going to be odd. Negative f of x is equal to f of negative x. They are the same. So therefore, they are odd. So this function is odd. There's a lot going on. So the first step is always replacing x with negative x. And if it's not even, multiply the original function and write too fast. Your original f of x by negative 1. And then if you multiply it by negative 1 and it's the same as f of negative x, then it's odd. Any questions on this one? There's a lot going on. There's a lot going on in this problem. Now here's the easy one. Yeah, this one is a doozy. So again, we still trying to figure out odd, even, neither even nor odd. So we had an even one, the odd one, and I bet you $50. This one probably neither. So you have this absolute value here. And we have this formula that says if the absolute value of negative a, which is some number, is going to equal to the absolute value of this a. Once we put a negative inside of the absolute value bar, then if it's negative, it's going to make it positive. Just go with it. Just remember this. So let's see that. So we want to know if it's even, odd, or neither. So the first step is always change x to negative x. Let's rewrite it. So the first step is always changing made that a different color. So we're changing x to negative x. And when I do that, I get, for the first one, I get negative 8x. There's no, it's not being raised to a power higher than 1, so it just stays negative x. Multiply that by 8, you get negative 8x. So now, according to this little formula I wrote here, negative 8x is going to change to positive 8x. So now I have negative 8x, negative the absolute value of 8x. So f negative x is equal to negative 8x, negative the absolute value of 8x. Let's see if f of x and f of negative x are equal to each other or are the same. I'm over here, my voice sounds raspy, sounding like Rick James or James Brown or something. So the original function, I wrote that, and then my new one of f of negative x is negative 8x, negative 8x. So they are not the same because of my 8. I have a positive 8 and a negative 8. So therefore, these two are not equal, so it's not even. So now let's see if it's odd. So the way to see if it's odd, we want to multiply the original function. So we want to take the original function and multiply it by a negative. So you put a negative in front of the original one. And it's just going to change all the signs. So now I have negative 8x plus the absolute value of 8x. Now I just need to see if these two pieces x is equal to negative f of x. And so when I look at them, they are not equal. They're not the same. So it's not odd either. So it's going to be neither. So this one is neither. Pen is acting up. So f of negative x is not equal to negative f of x. So since it's not even, it's not odd, it is neither. Any questions on this, on even, odd, or neither so far? Still sleeping is Monday. So that's even, odd, and neither even on the function, the symmetry, and we looked at the symmetry, even, odd, or neither. So I'm gonna stop this.